Hello friends, welcome back to my YouTube channel after a long time. So I was busy in some work in my yeah. So I have a plan for next 20 to 25 days. Okay. So this plan is to give you a whole lead code tutorial for graph algorithms I will solve some question related to that algorithm, this question number of distinct island is entirely dependent on this algorithm called DFS. So these 20 to 25 questions that are coming in coming days is comprises of whole graph algorithms, like most of the graph algorithms like DFS, BFS, shortest path using BFS, or shortest path using Bellman-Ford or Dijkstra, then topological sort, then A star algorithm, etc. So in this way you can see yourself a good strategy for graph algorithms, to get a good grasp on graph algorithms. So let's start our first day in this graph tutorial. like our first topic is DFS, depth first search. So as the name applies, depth first search is we have to go deep and deep. like uh, if we For example, this uh, let's see the question first and then I'll explain you to the graph. Okay, or DFS. So the question is number of distinct silents. Okay, so the question is, given a non-empty 2D array grid of zeros and one, an island is a group of ones connected four directionally, horizontal or vertically. Okay, you may assume all four edges of the grid are surrounded by water. Okay, so the we have to count distinct islands, and the definition of island is an island is considered to be the same as another if and only if one island is can be translated to equal another, not rotated, not reflected. Okay, so for example, this whenever we see one, we have to go deep, like deep in the until we have no one there. like uh, if we find one here, then we have to go to four directionally, in this direction, then in vertical direction, in horizontal direction, up, down, left, right, these four direction. So and until we not able to find any ones, and count this as one island, like 1 1 1 1. So we can use DFS for that. So but the question says we have to count only the number of distinct islands. So we have to keep coordinates keep track of coordinates of our uh, islands. Like if we see the same coordinates, like we see the same coordinates, yeah. So let's see, there is this one, uh, start from zero, origin. Okay, let's suppose this is origin. Okay, 0 0. So 0 0, then 0 1, then 1 0 1 1. So this is the whole coordinate. Okay, and let's see for this island. Okay, 0 0 0 1 1 0, then 1 1. So you can see that this both island has same coordinates. Like we have 0 0 0 0, then 0 1 0 1, then 1 0 1 0, then 1 1 and 1 1. So they are identical. So we can now conclude that this is the same island. So we have to return the number of distinct island, not the same island, not all the island. So we now see this is same island, then we have to return 1. In the same way, in second example, 1 1 and 1, so the coordinates is 0 0 0. Always the first letter we see is the origin. We assume this as the origin, so in that way we have we can take track of all the ones in our island, like in our current island, like 0 1 0 0, this is 0 0, then 0 1, then 1 0. So this is the coordinate of this island, this 3 island comprises of 3 1, and the coordinate of this island is 0 0 0 1. And in the same way, 0 0 0 0, then 0 1, and it's like that only. Yeah. So we now see that this is identical to this, so we have only 3 islands, because out of 4 islands we have 2 identical islands. So let's see this in code. Like, okay, let's say this in the code. So I'm using set for determining this ordinate is identical or not. Like, set is used to store the unique values, like yeah, the set not comprises of any duplicates, so it is very useful for this question. Okay, so let's do this question. So I have just have to see the edge cases. If grid size is equal to 0, then we just have to return 0 because there is no island. Okay, now I am using set and vector of pair. Okay, so vector of pair, like this this pair consists of I and this is j, like 0 0, then 0 here and 0 here, then 0 1 0 1, then 0 here, 1 here. In this way we can keep track of all the coordinates. And now we have to trace all the points. So if there is one, okay, so okay, we found an island. So now we have to turn all the ones connected to this island to 0, so that we cannot revisit that island and count the redundant island. Okay, so now here the BFS comes into picture. Okay, now we have to declare our coordinate vector that comprises of coordinate of my whole island, every one of this island. So let's see, let's say core. Okay, now I have to that first search for all the connected ones, so that we don't have any redundant value. So for that we have to we have to use grid, then coordinates of 1, current coordinates, then current coordinates of 1, like we have to use this, right, 0 0 for this and 0 0 for this also. So I'm using that, and coordinate obviously. And after performing the whole DFS, we have to insert this in our set. This vector says that. Yeah. Then at last we have to just return the size of the set, because set don't comprises of any duplicate value. So now we have distinct island. So now we have to write DFS function. So let's write this first. And vector of pair. Yeah. So now we have to see our termination condition. So TFS is like a recursion. Okay. So every time we see recursion, then we can say that there is DFS, like, because we have to go deep and deep in that problem. So yeah. So every recursion has a termination condition. So now our termination condition is like, if there is 0, then we should terminate at that point. If and also if there are out of bounds, like out of 0, out of whole grid dot size, like size of the grid. So this is all the termination conditions. If 0 or equal to grid dot size, or grid of ij equal to 0. Okay, then we just have to return. This is the termination condition. Now we have to write our current coordinates to 0, so that we cannot revisit will not revisit in future this, and don't count more. Okay, now we have to add the coordinates of this, so that we can add number of distinct islands. Okay, so for that coordinate we have to push back just the, yeah, just so, yeah, x and j minus y, or you can do also x minus I or y minus j, it doesn't matter, because yeah. So this is the coordinates. So now we have to see every possible direction, like we have 4 direction. Okay, so we have to go all the 4 direction. So let's move to the 4 direction. Yeah, sure. So this is 4 direction, left, right, and up, down. So this is the whole problem. So yeah, I think this is it. Now, oh, there's one more there. Yeah, so this is it. What happened? Oh, sorry. So this is it. So hope you like this video. Hope you find this video helpful for your graph data structure or DFS. So tomorrow I'll be back with a new graph algorithm, probably BFS. So let's see what's I have for you. So thank you. Comment, like, and subscribe if you like this video, and don't forget to put uh, put the on put on the bell icon of this, like here it is. Okay. So bye. Good night.